So let's go ahead and take a look at what we've got here. We've got circle O and a radius is 12, and we have a central angle of 60. So the idea is, how can we find the actual length of this curved arc here from A to B? Okay, and it's a straight line distance, but we're going along the circle. Well, the formula I want you to know is we're going to take the entire circumference, so the distance all the way around the circle, and multiply it by which part of the circle we're talking about. All right? So here's what we do. We're going to take the entire circumference of the circle, which is 2 pi r, and we're going to multiply it by which part of the circle we're talking about. Now, if we're going to only go, say, halfway around, that's 180 degrees, but we would take the entire circumference and divide it by 2, or multiply by 1/2. Let's say we're going to go 1/3 of the way around the circle, so it's going to be 1/3 of the circumference, and so on. That's the basic idea, right? All right, so what we're going to do is, to determine which part of the circle we're talking about, we're going to take the central angle from the arc, okay, the central angle, and compare it to the entire circle, which of course is always going to be 360 degrees. Okay, now in this practical example here, with the radius of 12 and the central angle of 60, we're going to take 2 times 3.14 times the radius of 12. Okay, let's make that a multiplication dot there. Sorry about that. And we're going to multiply it by the 60 degrees over 360. Okay, now it's, of course I'm showing this in degrees. Now of course the next step is to just multiply and simplify whatever we've got here. So if we look at the 60 and 360, we can simplify by dividing out a common factor of 60, which is going to be a 1 over a 6. And then I notice here that I can factor out a 6 out of the 12 and a 6 out of the 6. And so now we put it all together, which will give us 12.56 in the end. Now normally, at least in the purpose of these videos, we're going to round to 1 decimal place. So let's call that 12.6. And it's a straight line distance, and it'd be inches, of course, right? Okay, so again, take the entire circumference, multiply by which part, which is the central angle, divided by 360. Okay, fairly simple. Now let's work through a couple of examples together. All right, in number 1, the radius is 14 miles, and we have a 240 degree angle. So of course we're talking about the actual curved length here of this arc. All right, so the entire circumference is 2 pi r, so that's 2 times pi times 14 miles. And then we're going to multiply it by the central angle, which is 240 divided by 360. All right, so we're going 240 degrees around a 360 degree circle. All right, let's simplify. Common factor of 120 right there, so that's going to give me 2 over 3, and multiply this whole thing out, which is eventually going to give me 175.84 divided by 3, and now it's going to give me 58.613. Let's call it 58.6. Okay, now that's going to be miles, and that's going to be my unit there. All right, let's try number 2. All right, do you remember the formula? Yes, we're going to take the entire circumference, so that's going to be 2 times pi times the radius, 2 pi r. The radius in this case is 16 miles. And we're going to multiply it by the part of the circle we're talking about, which is 270 over 360. All right, let's simplify this. These degrees here can be factored out. We can take out a factor of 90, so that leaves a 3 on the top, a 4 on the bottom. And I know that the 4 and the 16 can be factored here, so that'll leave a 4 and a 1. All right, what's left? This gives me my final answer of about 81.6, okay, miles. All right, so you got to know the radius of the circle, and you have to know the degree of the central angle that creates the arc, okay? Remember to think about which part of the circle you're looking at.